Hi guys, I welcome you all to my channel CSNet Lectures. So in this session, we are going to discuss about another very important topic of Q data structure. It is nothing but applications. So we are going to discuss very important applications of Q data structure which seems to be asked in examination point of view. Okay friends, so along with this, we are going to discuss an important problem of a Q data structure. Okay, so suppose if any viewers who didn't watch my previous videos of Q data structures and its algorithms, its manual operations, I request you to watch and then come over here so that you will be able to follow my all the sessions. Okay, so I will give all the links in the description. You can go and watch it. Okay friends, right. So friends, these are the different types of important applications where a queue is being used. That is, a queue data structure is being used. Okay. So first I'll just give you a short description of what is the meaning of queue. Okay. So what is a queue? A queue is using first in first out method. That is, we are going to arrange the elements in sidewise. That is, we are going to make the elements to stand in line. The element which is present in the first location will be getting the first chance to move out of the queue. Okay, so the elements which are going to arrive at the last will stand at the last of the line. So that is the meaning of a queue data structure. So friends, these are the different types of applications under which queue data structure is going to be used. Suppose if you just keenly watch all the applications which I have mentioned here, all these is going to come under the function of operating system. Okay, so queue application is going to deal with the functions of operating system. Okay, so now I will tell you what is an operating system. So I think you may know what is an operating system. So it is nothing but it is going to manage the overall activities of a computer system. Okay, so without operating system, we cannot do any type of processes. Okay, whether it is a hardware function or whether it is a software function or any type of applications, okay, whether it is system functions or whatever it is, all the applications, that is all the software applications or hardware applications, everything is managed or controlled by operating system. Okay, so for that we are going to use two types, that is processors and resources. Okay, what is a resource and what is a processor? Okay, all these things we are going to study in brief when we are going to discuss about operating system subject. Okay, I'm just going to tell you in a line about what is processor and resource in order to understand this application area. Okay, friends, then next thing is you just have a memory of these types of applications. They may give that in what area queue application is being used. So you just going to tick the answers. Okay, so just you must have to remember that these are all the applications. Now we don't want to go in detail about all these types of areas. Okay friends, so now I'll tell you what is a resource and what is a processor. Now what is a resource? As I told, in operating system we need processors and resources. So resources are nothing but a computer system. Okay, in a computer system we may use CPU, central processing unit, or input output devices, memory, and so on. So an operating system is going to act as a manager to manage all these areas. Okay, because if I have a system, in that system at a time I may access many applications, isn't it? For example, if you take a mobile phone, in a mobile phone, while I am just using my Google data, at the same time I will be opening my WhatsApp message. Okay, again at the same time I will be watching my YouTube videos. So all these things, if you see, all are some processes. Okay, so how all these processes are being managed? So it is managed by using operating system. So all these processes are given a sequence, or it is being given a timeline. Okay, so based on the arrival time, so all these processes are going to get executed. Okay, so by using the resources is going to get all the processes which are going to come from many types of users. Okay, suppose if a process is needed for input output operations, okay, so the operating system is going to give that based on whether that input output device is free or not. If it is free, that incoming process will be allotted. If it is not free, it will intimate that is incoming process to wait for a certain amount of time. Once it is free, the input output devices will be allotted. So now this IO device, that is input output device, is going to be a resource. Similarly, CPU is one type of a resource. So what is a CPU? A CPU is going to do all types of logical, mathematical or any types of operations, and it is going to give the answer to the users, isn't it? Suppose if there are multiple operations that is being carried out by a user, that is, for example, he may open a program on C and he will be executing, or he may open a Python program and he will be executing, isn't it? So there are multiple programs that he may execute at the same time, that is multiple, I mean by opening multiple windows. So what the CPU will do is, it will accept all the processes that is being coming, that is all the processes that is being coming from the user. Suppose if this CPU is free, it will let in the waiting process, otherwise it will ask it to wait for a certain amount of time until the CPU is free. So once it is free, the process will be coming inside, that is the first process which has arrived will be coming inside. Okay, so that is in the queue format, all the processes will be standing. Okay, so the process which has arrived first, that will be entered into the CPU. Okay, so if you just imagine and see, all the points which I have said is going to come under queue, right? So the processors will get the resource, whether it is a memory or whether it is an input output devices or whether it is a CPU, based on the arrival time. Okay, so based on the arrival time, the CPU is going to get allotted. Okay friends, are you all clear now? So CPU allocation, so CPU is a resource will be allotted to a process based on this queuing function. So next is resource allocation. What is resource allocation? So CPU is one type of a resource. Generally they have mentioned resources allocation. So resource is nothing but it may be input device, output device or a memory, okay, or a CPU. So among these resources, which process, that is based on the type of process, that is based on the type of execution that I want to make, that resource will be allotted if it is free. Okay, so suppose if the process wants to take a printout. Okay, so if a process wants to take a printout, if the printer is available or if the printer is free of any service only, it will be giving it. Okay, otherwise how it will give? It will not give, isn't it? So the incoming process has to wait for a certain amount of time until the printer is free of work, isn't it? So that is a resource. Printer is a resource and the processor which needs a printer is a processor. Can you understand? So that is called resource allocation. So next is scheduling. So what is a scheduling? I am going to allot all the processors in a queue. I'm going to make the processors to stand in a queue. So based on the arrival time. Okay, so what is a queue? So queue is going to send the process which is arriving at the first, isn't it? So that is called scheduling. We are making all the processor to wait in line until the respective resource is free. That is called scheduling. So next is batch processing. So what is batch processing? So this is one type of an operating system. See friends, there are many types of operating system that we are using. Okay, so it is for example multi-user operating system, multitasking operating system, distributed operating system, real time. So like this we can go on till. So one type of an operating system is batch processing. So this is an operating system which is going to arrange the incoming processes in a group. It may be based on type or it may be based on time or it may be based on size. It is going to arrange the processes in a group and it is going to allot the resource. Okay, can you understand? That is called batch processing operating system. So the next one is priority queue. So what is a priority queue? So we are going to allot the resources to the process based on setting up of priorities. Okay, like precedence of operators we have discussed, isn't it? So like this we are going to give precedence for processes based on the highest priority. That process will give the that process will be allotted with the respective resource friends, right? So that is called priority queue. So next is in reservation we are using this queue. That is nothing but any projects, that is it may be a railway reservation, or it may be a ticket reservation or airline reservation or whatever it is. So in that case we are using this queue implementation for developing these types of projects. Okay, so next is queuing theory. So what is called as a queuing theory? It is nothing but it is a theory, that is a mathematical theory which is used for dealing with processes which are waiting in line. Okay, we are going to deal what we are going to do if the processes are waiting in line. Okay, so that is called queuing theory. Okay, so next is resource simulation or simulation. So what is called resource simulation? That is the other name is simulation. So the resource may be of any type, right? It may be a central processing unit, or it may be a memory, or it may be a input output devices, and so on. So we are using simulation for doing the resources management. So what is called as a simulation? So generally if you see, this word will be often occurring in machine learning. Okay, under machine learning we will be using this simulation implementation. So I just want to tell you in brief what is a resource simulation. Okay, there are resources which are having a self-learning concept. So what is called a self-learning activity? So it will be pre-known with the knowledge that there are certain processes which will be coming. You take that process, execute and give that. Okay, because already it has been trained with certain number of processes. If that process is present, you do this work. If another process is present, you do that work. So like this, we are training these resources. Okay, so the training may be given for CPU, or the training may be given for input output devices or a memory. Okay, so once if another new process is going to come, okay, if another new process is going to come, based on the trained rules, based on the trained rules that is being implemented in it, it will take that process and it will do that work. Okay friends, so it is nothing but training and testing. So these are the two words which we will be using in understanding machine learning concepts. Okay friends, so now if you see, I have given a brief description of queue applications. Okay friends, I just want to tell you that in order to understand these applications I have said, it is not needed to know in deeper manner. Okay friends, so in short I will just tell you, CPU allocation is one type of an application, resource allocation is another type, scheduling, batch processing, priority queue, reservation, queuing theory, resource simulation or simulation. So these are the words that you will get in MCQ. So by seeing these words, you can easily mark that these are all the very important applications of queue data structure. I will just tell you which they may be asking it to you in frequent. So they will ask resource allocation or scheduling, that is job scheduling, and this one, and priority queue. These are being frequently asked in examination friends, right? I think so now you will have a clear idea about queue. Okay friends? So friends, now we are going to discuss about a very important problematic structure of a queue data structure. Okay, so I think so it will be very easy for you if you just follow my way of explanation. Okay, so before discussing this, so once again I will just tell you, please watch all my previous videos, and I also want you to understand the concepts, so only you will be able to understand the different types of problems which I am going to give it to you in the future. Okay friends, so shall we proceed? Right. So first let me read what is the problem being given. Okay. So the initial configuration of a queue is A, B, C and D. So they have given that configuration of a queue is A, B, C, D. So what is called configuration? The original structure of a queue. So the original structure of a queue is A, B, C, D. By being that A has to be the first element. So there is a queue data structure. Okay, so there is a queue data structure. So queue data structure is having the elements as A, B, C and D. They have mentioned that A is the first element. See, as A being the first element. Okay, so after this I think so you will be having an understanding. So Q is having 2 pointers, isn't it? So front pointer is going to point to the front location and rear pointer is going to point to the last element of the queue. Okay, so we are going to delete the elements that is being pointed to by the front pointer and we are inserting the elements in the position of the rear pointer. Okay friends, so now to get the configuration D, C, B and A. Okay, so we are going to take the same configuration and we are going to do some alterations in this configuration so that your final answer will be D, C, B and A. In order to get this, what I should have to do? How many number of additions I should make? How many number of deletions I should make? So that is being given as your option. Friends, are you all clear? That is, we are going to use the same data structure. This is the data structure. I am going to alter the structure so that my final output will be D, C, B and A. What I should have to do? So what is the first element? D has to be your resultant first element in the queue data structure. Okay, so what I can do? I will start to delete this operation because these are all the elements which are present previous to that of D, because D has to be your first element, isn't it? So I can remove one element. So now what will happen, you see? So front pointer will be pointing to this location A. So first you remove this. So I am removing A. Okay, A is being removed. Okay, so now front pointer will be pointing here. Okay, so now I am removing B also. Now C will be pointed by the front pointer. So now I am going to remove C. Okay, so should I have to remove D? Tell me, should I have to remove D? So no need, because it is an extra operation, because this element is going to be your first location. So don't want to remove, because it will take time for once again deleting and once again removing. Okay, so all these factors also you should have to keep in mind, because we are going to do internal programming. Okay, so that we are not going to discuss over here. We are just seeing the overview of what we are going to do, that is a manual operation. Okay friends, so by considering the time factors, we are not going to remove this D, we are placing it as it is, right? So now what I should do? So how many number of deletions I have made? 1, 2 and 3. Okay, so this is your first element removed. Okay, so this is your second element removed and this is your third element. So now I am going to alter this queue data structure. So let me draw a queue data structure. That is, I am using the same configuration, isn't it? So I am moving this D as my first element. So this is my front pointer, isn't it? Front is pointing here. Now at currently rear is also pointing here, isn't it? So now I must have to insert the remaining elements C, P and A. Okay, so how I will be inserting? So take C, because order is being given here. Based on the sequence only I should have to insert. So insert C. So C is being inserted by moving my rear pointer. Okay. So now next is B. So B has to be removed. My rear pointer will be pointing here. So next last I must have to insert this A. So rear pointer is finally pointing to this location. Okay friends. So now if you observe, the configuration which they have mentioned in the question is being got. So now from the options, can you just tell me which is the right answer? So the right answer is 3 deletions and 3 additions. So we have inserted 3 elements and we have deleted 3 elements. So this will be your answer friends. Okay, so I think you will be clear in this way of solving the question. Okay friends, In this session, we have discussed about its various type of applications and one of the very important problematic structure of queue data structure. Okay, so in the next session, we are going to take up with another one problem of queue data structure by having combination of queue and stack. How we are going to solve it? So that we are going to see it in the next session. So friends, I request you to subscribe my channel and give me your likes and comments so that it will be a great motivation for me to continue putting up my videos. Okay friends, bye and thank you.